Good evening, everybody. Evening for me. I hope everybody is having a fantastic morning, day, afternoon, evening, night, wherever either your time zone or your sleep schedules put you. Uh, this is the first time I'm actually doing this sort of a solo event. Hopefully, this will be part of an ongoing series, but there'll be lots of bugs to figure out. So bear with me. Bit of an introduction. Um, I go, this stream goes under Prof. Cruiser, and I really am a professor. For those of you who don't know me, I recently retired from Ohio University, where I've taught IT for about 30 years. And especially my international students always called me Prof, so I went with that. On Twitch, I'm more likely to be known as the Ancient One. So yes, that is me. I am the Ancient One. Uh, I'm not. I don't tend to stream off of that account anytime soon. That's more of my account I use for viewing other channels. So again, welcome. So the um, the the underpinning of what I intend to do, and I'm going to hope to do this once a week, and not for very long. We'll go for an hour and a half. Um, what I realized is I'm not an expert, not even in IT. Uh, I don't have an IT degree. When I started teaching uh, what back then was called telecommunications, there were no degrees in telecommunications. We all came from different places. Uh, when I um, when I worked in industry, I've been a consultant. I've never actually run a communications network, but I've been a consultant. And when I ran a consulting group, I had, I think, a one computer scientist, a mathematician, and an astronomer and a Navy chaplain. He was the only one who could had the patience to read government documents. So it was, at the time I started teaching, there were no formal degrees. So I spent 30 years basically learning this stuff I taught my students. And so these streams aren't scripted. Uh, I had to, really keep myself from doing that. Um, what I intend to do is just give everyone a kind of behind the scenes look at what I do to actually figure stuff out, and get ready to teach something, or just because I want to figure something out. Some weeks I'll have an agenda, and I will have for the next few weeks, because I've been asked to put together a class on what we used to call voice applications or voice over IP. It's really going to morph more into how does this stuff work that we all use nowadays with the pandemic: Zoom, Teams, Cisco WebEx, Discord, all that good stuff. And so a lot of things I'm going to do today and in the weeks to come are going to be sort of centered around figuring out all the different tech that I need to teach to my students at some point. Um, so that's kind of the underpinning. Now, hopefully, if we actually have people in here and people are interested, the I'm totally open to meandering off into. I probably meander off myself, anyways, but I'm certainly perfectly open to meandering off into the weeds and look at other things. So if we want to do that, we can. Not a problem. But for now, at least I'll have some ideas as to what kinds of things I want to look at and sort of figure out. If there's a couple of ways to stay in touch. Again, I'm only going to stream at most. Right now, I'm just going to plan to stream maybe an hour and a half a week. So outside of the streams, I have Twitter, which is in you can get my it's in the panels below, but I also have an exclamation mark Twitter command in the chat. And I have a Discord server that I just set up, so it's brand new. We'll figure that out if anyone wants to get a hold of me there. And of course, if there's anyone here from um, from the McClure School where I used to teach, they do have a Discord server as well. I'm in there, and so you can hit me up there as well. But Twitter is probably probably the quickest way to get a hold of me. I think I have my DMs open there. I'm pretty sure I do, but just, tweet at me. All right. So with that introduction out of the way, um, the so the intent today is that I need the first thing I need to do when we start talking about how, in fact, how does Twitch work, right? Or how do any of these applications work? One of the things I need to want to understand is why does it sometimes not work, right? And so I was in ODG's channel just now, and he was having some problems with his channel. There's one of the Twitch streamers I watch a lot, Co-Carnage, spent, I think, 4 years not having a stable stream. It was pretty good, but a few times a week to a few times a day, his stream would drop, and he could not get it fixed. He lives in a rural area. His internet was good for some parts, but not good for Twitch. And so so one of the things that I was going to poke around and say, what tools do we have to actually figure out is my connection good, or if something's not working in a corporate network, why is it not working? And so so how do we measure that stuff? How do we figure out if it's actually going to work or not? So I think, let me pop up a window here. So I think what everybody's probably familiar with is speed test. I think that's the right URL. There we go. Now, let me point out that there's a very good chance that I'll take my stream down within the first 5 minutes of being live, because I'm about to run a performance test on the same internet link that I'm just streaming on. Right, so if we go offline, bear with me, I'll be right back. But I think probably everybody has played with this. These guys are everywhere. I mean, I've got the browser up here, but I think you can get an iOS app, an Android app. I mean, you can all sorts of stuff. And so what they're trying to do is sort of tell you how good is your internet connection. So let's see what this thing actually does. Keep your fingers crossed that we're not going to go offline here. And so you get an indication of your download capability. I'll talk about that ping in just a second. And now it's going to be impacting the stream. It's going to run the same direction as the stream. It's going to try to see how fast I can send. So I'll let that finish. We're still here. That's good. Dropped a few frames, but not very many. So this is useful in some cases, but not for what I'm trying to do. What I'm trying for this class or for things like Twitch. So what this test just did is it tells me that, first of all, between my house and a server at a Rec Squared, I think, is a hosting company in Columbus. So between my house and a big data center in Columbus, there is a 16 millisecond delay. That's what so 16 millisecond round trip, and we'll look at that, and we can play around with that in another context in just a second as well. So that tells me that if I send a message to that particular server, it takes 60 milliseconds to get an answer back. Now, if you do gaming, obviously that makes a big difference, right? So gamers talk about that. This is the latency or the ping time that gamers talk about. And if you have if you play something like Tarkov or PUBG or even Path of Exile, which I play, you bring up a list of servers to connect to, and it'll tell you the ping time, and that's exactly what it is, how long it's going to take for an answer to come back. And so that tells you, how quickly things can respond. Yes. yes, PX Slip. I wish I wish I could afford to live in a big city with 400 symmetric. That would be lovely. All right. So the hi John. Um, oh, thanks for stopping by ODG. But unfortunately, my Nightbot doesn't like symbols, so I apologize. I know your symbol art is PG, but my Nightbot doesn't like it. My apologies. Um, Pixel, if we could shout out Old Depressed Gamer, he is a good friend. I've been watching for quite some time. I was just hanging out in his stream a little while ago. He was paying, I think, Payday, which again is one of those games where where you'll want those ping times to be low. And I can move my audio up a little bit. Thanks. So as John was pointing out, so my internet service is set up to download at 400 megabits per second and upload at 20 megabits per second. So clearly, these aren't useless numbers, but they're not super helpful. And the reason for that is that if I look at my Twitch stream. Let's see. There it is. Right now, I'm sending video at 2.5 to 2,500 kilobits per second, about 2.5 megabits per second. So, arguably, you would say that my 20 megabits per second upload speed should be plenty. Well, it might or might not. And the problem here is that the speed test is only concerned with uploading or downloading stuff. It isn't concerned with things like gaming, other than the ping time, which is useful. So let's take a quick look. See if I can figure this out. I've never actually used this one before, but it looked kind of cool, so we'll use it. It's kind of a Google whiteboard sort of app. So let's see. I want a pen is good. Okay. So let's just say, I am here. What what speed test says is it says if there's a server up in Columbus. What is how quickly can you transfer information in bulk from Columbus to my house? And obviously, how quickly could I transfer information from my house to Columbus? And that assumes that I've got a big chunk of data, and I'm going to chop that up into messages or packets, and I'm going to send one of these packages at a time. If something gets lost, there's essentially a message that comes back. It's not quite. Those of you that know about TCP know it's not that simple, but conceptually, if I send something, it gets lost, a signal comes back, I can send it a second time to get it in, and ultimately what speed test measures is how quickly can I get through that process. Problem is that let's see, there is an eraser here somewhere. That's a laser text box square. It's got to be over here somewhere. There we go. So let's get rid of this stuff and see what we really want to do. First of all, I'm not entirely sure that I'm interested in sending stuff to that big server in Columbus, but that's we'll figure that one out in just a little bit. But I'm really not super interested in transferring, sort of bulks of information in bulk. It's got to be. I guess it's probably faster to erase the frame and do it over, isn't it? We'll do that next time. So what I really want to do is I want to send audio and video. And the problem with audio and video is a little bit different. So in audio, we talk about samples. And so an audio encoder generates sort of an equally spaced series of samples. In video, we talk about frames mostly because they're bigger. So in video, I create sort of equally spaced frames, and they're not necessarily the same size because of some trickery that we play with. Some trickery that we play with encoding video. The problem is, in order for the receiver, so the good folks over here, for them to actually hear that audio, it needs to really kind of show up there more or less the same way. That's not going to happen. First of all, there is going to be a delay. Not much we can do about it. That's where that ping time is useful. Right? So that ping time was really, really big. Then the audio would be delayed. Not a good situation. But not much we can do about it. It just makes two-way conversations harder. Normally, it doesn't matter so much if we don't hit 100 milliseconds plus. I remember doing experiments over satellite circuits, and that will drive you batty. The delay is just long enough that you say something and the other person tries to interrupt you. Of course, you don't hear it until a quarter second later, and by the time you hear it and stop, they assume that you're not going to stop, and it's really messy. So lower delays, not a huge problem. What is a problem is if this stuff ends up showing up with the wrong spacing, right? So I get this one, and I get the next one over here, and I get a couple of really close together, like that. That's really hard to reconstruct the information again. So if the distance in time between the packets changes, then if it changes dramatically, I have to compensate for that, and I have to compensate for it by sort of buffering up a bunch of stuff so that the decoder has something to work with, which means I introduce more delay. So if we're trying, and again, remember the target applications that we're sort of interested in are things like Teams or Zoom meetings, Discord, where we're trying to talk to each other. And if I'm in a Discord with a bunch of other gamers, it's no good if there's too much delay between somebody saying, "Hey, you need to turn around that corner," and me actually hearing it. That would be bad. So the change in so here my packets are nicely evenly spaced. Here, these are too far apart, and this one is kind of small, and this is really small. That difference is called jitter, and so we need tools to work with that. And I remembered when I started to look at this, I remembered at some point there was a cool tool called iperf that I used a long time ago, and it turns out that tool is still around. Although it got a little bit more complicated than I thought initially, because there's apparently two versions of it. And so, let's see. So there's iperf, and then there's iperf 3. So these guys here are some of the purveyors of iperf. It's a French site. So there's a branch that happened here. iperf was a pretty is a pretty old tool. I think I've used it 10, 15 years ago. But it's undergone continuous development, and eventually it looks like this whole thing forked, right? And so there is a GitHub page here. I think this is strictly iperf 3. And at the same time, I'm pretty sure that on SourceForge, there's also a project, and this one is iperf 2. So one of the things that I don't think, I'm not sure I want to spend a lot of time on that tonight, but at some point I have to figure out what the differences are. What I already noticed when I was playing around, starting to play with this, was that first of all, the two versions are not interoperable. The iperf 3 branch, I think, was developed primarily. I don't know if the wiki has anything here. So this was developed under the auspices of the Department of Energy, I think, and it was meant. ESNet, Lawrence Berkeley Laboratory is where this is being released. And then iperf 2 apparently got picked back up after it went dormant. So that's kind of what happened. And so this one, it looks like the last release of iperf 3 was in August. So it is pretty actively developed. Right. So the first thing to do here, I think, is, let me see. I don't think I have it on my. So I'm on a Windows machine, just to set the stage here. I'm on a Windows machine, but I'm going to run it in WSL. The reason for that is that when I went to download over here, when I went to download the iperf for Windows, the latest version is 4 years old. So whoever created these binaries hasn't created them, at least not for not put them on this site. And just in a cursory look, I didn't find them anywhere else. I'm sure there's a way to build the new version on Windows. Right now, I'm just not quite sure. I would prefer to just install stuff. So what I'm going to try and do here is just run this in the Windows subsystem for Linux. So I'm going to pop this down here. I'll just make sure I can find it again later. So let me pop that guy up. So we're going to bring up. Let's see. Let's make sure we make this large enough so people can actually see it. All right. So what I'm going to do here is, I don't think I have iperf installed here yet. Nope. Or iperf 3. Oh, I do have iperf 3. Okay. Let's see what version installed here. All right. Yeah, I think I better make this a bit bigger, huh? Hopefully I can still fit stuff on the screen, but we'll see what happens. There, that should work. I have to sort of account for the fact that I'm streaming in 720. So this is version 3.7, which isn't half bad. It's not 3.9, but so this is what I got from the Ubuntu 20 repo. All right. Let's see. The other thing I need to do here is, otherwise I'm going to drive myself nuts. Um, whoops. Yeah, I'm gonna have to. I need to set up. I am going to set up a set of SSH keys and get that configured because I'm going to want to connect to other machines, and I really don't want to type passwords all night long. So let's do that real quick. Right. Yeah, RSA is fine. We're going to call this WSL20. You'll see what the NP is for in just a second. Because this is going to be ephemeral, I'm going to take this out anyway. I'm going to not put a passphrase on it. For security reasons, you really should. So now I should have my public and private keys for SSH. Now, the other thing I need to do here is to... I really want to put this in the SSH agent, so I need to get that one started up, which is really weird. I think I remember how to do this correctly. If you haven't done Linux command line stuff in a while, and I do it sort of on and off, and I'm hop between Linux and Unix and Mac OS, which is a Unix variant. So this is a weird one. It's basically a keychain manager, but the way it starts up, it actually produces a bunch of commands. So you have to tell the shell that you want to execute that, and then I should be able to add that key. Cool. All right, so that worked. Now, first machine we're going to go to is another machine here in my house. So let's copy the public key to if you haven't noticed already, I can't type. And we'll call it the same thing. WSL GNP pub. All right, so that should get it over to my Linux machine. And of course, I'm about to password in the first time. Whoops. Oh yeah, right. Now we need to SSH over there and set it up. I'm lazy. Okay, I already have authorized keys. So what I'm going to do is that should do it. Okay, looks good. Now let's see if we can get back in there without a password this time. Yep. Okay, cool. So the other question I had was, do I have iperf 3 on here? I do. Same version. It's the same. This is a Debian Linux machine, but the repo is essentially the Ubuntu repo, so that makes sense. Right, so now what we can do, I need another window here. All right, so what I'm going to do is on my on the machine that is basically running in another room here in the house. What I'm going to do is tell iperf to run as a server. And it's going to do it interactively, so it's just going to be sitting there listening. So now I should be able to tell this one that I want it to be a client and send to that machine. All right, before anybody gets way too excited, this is of course over an Ethernet wire in my house. All right, so all I've proven now is that my gigabit switch is really a gigabit switch, but that's good. It's actually doing what it is supposed to do. All right, that of course is the same thing as thanks, Pierre. I'll do that next time. SSH copy ID. Okay, I'll keep an eye out for that. We'll do that next time. By the way, PXLip is most likely to join me for some of these streams. He's a web developer, and some of the stuff I need to do very much requires knowledge of how to use browsers to inspect code and figure out how to use containers and those kinds of things, and I don't. So he's going to help me out with that. All right, so this did the same thing that speed test did. It basically took a chunk of data and did a transfer between the two machines. That's not really what I want here. So let's so if I do, whoops, iperf 3. So let's take a look and see what options we have in iperf. All right, so I have to be a client or a server, which makes sense, but there's a whole bunch of things I can do in iperf to have it work a little bit differently, output different information, output information formats, that kind of thing. On the server side, I can run it as a detached server if that's what I want to do. But what I'm interested in is right there. Right, so video streams, audio streams like Twitch, Zoom, Discord. The audio and video doesn't use TCP, which is that bulk transfer that takes care of correcting problems. UDP doesn't do that. UDP sends data as quickly as possible, but doesn't worry about retransmitting. Right, so on like the Twitch performance, so if I look at my OBS here, it tells me that I dropped 98 frames, which represents 1/10 of 1%. But notice it said dropped. I didn't try to send them again because it would be useless. Right? Where's my? Let's see. I'm trying to find that. I think it's going to be here. All right. So in this scenario, right? If one of these frames actually got lost, right? By the time I turn around, remember there's latency. By the time I turn around and send it a second time, it's going to come in not only with a different gap. It's going to come in probably out of order, and the codec won't know what to do with it. So UDP will on purpose. I'll bring this one back up. UDP will on purpose not try to retransmit. That's why we use it for voice and video. So what we really want to do here is see if I can get what happens if I test the network using UDP. Oh, hi, Resurrection Fern. Welcome. Pixlip, if we can do a shout out for Resurrection Fern's channel as well. I think she's going to be on here in a few minutes. And if you're tired of my tech talk and want to listen to beautiful music, hop over there. I'll join when we're done here, whenever that is. You won't be sorry. So if you're not following her already, please do and check out her channel. So what we want to do is run the same test, but we want to have iperf say, don't transfer a bulk of data. That's not what we want to do. Send a stream of these disconnected frames or samples, and of course at that point I have to tell it how fast I want to run. The default for now is fine. It's a megabit per second. Remember, my Twitch stream right now is running 2.5 megabits per second. So something in that neighborhood will at least give us an idea what this thing is doing. So let's try that. So I'm going to do the same thing, but this time we're going to request UDP. And so let's look over here. So interestingly enough, the way iperf works, I've forgotten about that. The way iperf works is it when you tell it is the client, have a wonderful stream, Fern. We'll see you over there when I wrap up, and again, everyone is is here. Hop over there when you get a chance. This is an out of cycle day for Fern, at least for now. She's normally on Tuesdays and Sundays, so look for her on those days. Thursdays, I think, are coming back in the mix eventually, but this is an out of cycle stream for her. But hop over there when you can. Right. So the client is going to send the information, and in this case, the client can only tell us that it was sending roughly at the speed we asked it for, 1.1 megabit per second. And it tells us that it sends roughly 100 kilobytes or 120 kilobytes. So it took a little less than 100 datagrams to individual messages to do that. So it's sending roughly every 10 milliseconds. Yeah. All right. The server, of course, can measure. The server can, of course, measure what the distance between packets is, and it will do that. Now there's a bug in iperf that I don't totally understand. So this is milliseconds, right? And so the server says the first 2 packets essentially, or the first jitter measurement was something like 600 seconds. It's like 10 minutes or something. Not possible. We haven't been looking at it this long. So there's a bug in there where it doesn't set up correctly at the beginning. But once it stabilizes, I'm sending from one room in the house to the next, right? So when we're doing that, the jitter sort of settles down to a very small number, a fraction of a millisecond, basically. So this would be really good, but of course not terribly useful because I could just shout to the other room if I wanted to. Okay, but what we've established is that I can with this tool, uh, get a different view of how the network performs. And so what I want to do next here is to try and do this and go to a couple of different places that are not in my house and see if we can get this to work and get see what things look like. So I'm going to have to do I'm going to have to we'll leave this one open. Right. At some point, and when I first saw this, at some point, it's kind of interesting. This is sort of the side, the side alleyways we're necessarily going to end up heading down at some point. So somewhere I'm hoping I'm not going to head too far down that direction, but. So what I did is when I saw those jitter, one of the things I was wondering about is how does it actually do the jitter measurements? And so let me see if there's a faster way to find it. Right. So this is what it's supposed to look like, and what it does. Let me see if I can. There we go. I'm going to find it again. There. So what iperf does is it goes back to a standard RFC 1889, which is the standard that defines the real-time transport protocol, and that's the protocol that we actually use for voice transmission in particular, but also video, for things like Discord, for things like I think Zoom. I'm not sure yet about Teams. I think Teams, I believe, is based on a proprietary protocol that came out of Skype. I'm going to guess though that they're using RTP for the voice transport, that is doing the signaling differently. So this is a super widely used a standard, and so the good news here is that they're trying to do the same computation that that Discord or any of these applications will try to do, because if the jitter gets bad, the receiver has to adjust. And it has to adjust either by making its buffer bigger, and I need to at some point figure out a good way to visualize why that is. But you have to basically collect more stuff so you can even out the packets as they come in. But it also in RTP it reports back, and so. Sometimes now most of the time it's because Twitch is trying to save money and it notices that you switched off the tab. But sometimes you watch Twitch, you notice that your quality jumps down. Let's say in my stream, because I'm just a nobody. I'm not an affiliate. I'm not a partner. So as far as Twitch is concerned, I'm a nobody. So my stream runs at 720p. Which is the smaller dimension, so the horizontal dimension is 720 pixels. But you might find in your viewer that you drop down to a smaller number, 360 or something like that, if the connection is really bad for some reason. That happens more often if the streamer runs at 1080, and your stream gets bumped back down to 720. So we're not going to spend a lot of time there because I want to get to a few other things tonight. But this, and again, there's just bigger. This is the standards document for real-time real-time transport, and I think it's pretty old. It's 96, so somewhere in here. Let's find it. So actually, it's what I really want is that section here. I'm not. I didn't feel like digging through this whole thing, but this is where that output we saw from the server actually makes some amount of sense. Notice that it starts out with something bogus and then it drops down to it seems to sort of stabilize a little bit. And what's going on here is that the the jitter, which is that J here, is that J is jitter, and so it's getting computed as a sliding average, right? So it takes the packet interval that it just saw, compares it to the previous amount of jitter, multiplies that, divides that arbitrarily by 16, which is sort of weird. But somebody picked that. Somebody must have run some experiments. So that's a pretty good number, and so that modification gets then added back into the jitter. So the jitter kind of goes up and down, but it doesn't jump back and forth with every received packet, because this gets calculated for each data packet that comes in. So it doesn't actually jump back and forth erratically. It's kind of smoothed out over 16 packets. So in our case, we sent 90 odd packets. So for each of these reports would have had something like 10, 12 or so cycles of those 16. So it saw like 90 packets. And did that calculation 19 times. So from here to here, it would have sort of so it started out with some sort of idiotic number, probably because of a software bug of some sort, and so it takes basically a little bit of time before that algorithm that's now being fed proper numbers. That algorithm eventually kind of gets things back in order. So that's where we're at. All right, so let's try and see if we can hop into something that is a little bit more useful. So, whoops, I'm gonna kill this guy if he listens. There we go, and we're gonna exit out of here. Okay. Now I'm going to play the same game again since I don't have the handy dandy utility that PXLib was pointing out to me. So we're going to do the same thing again here. I want to send this key over to a machine and on the campus of the university. So let's do that. Send that to me at okay. SSH over there. Yeah, this got since that's the same series of steps every time. I'm not surprised there's a tool to make that easier. We'll do it the hard way. Okay, so since we're here already, we might as well go ahead and do what we can do. Now, I put iperf 3 on here a while ago, but this is, yeah, I'm not going to take the time today. So this is a much older version, unfortunately. But for the simple stuff, I think it's going to work well enough. So I'm not going to worry about it. I found out looking around earlier and said we might do this next week in next week's stream before we jump onto other stuff. In part because Pierre Slip can help me with that. There is a so this what we're on now. The machine I just signed in on is Mac OS, and there is a package manager called Homebrew, which actually is actually recommended for installing a newer version of this utility. So I want to try that out, but I'm going to try it out next week. There's some other stuff I want to do today. So I'm sort of curious. I want to see some different measurements. So we're gonna hope. So we might get less than stellar, not performance in the sense of speed, not stellar compliance by this thing, but we'll sort of see what it does. So same thing. I'm going to start up the server. So now I'm going to same thing here, except we're going to jump over to that machine. And so again, since I'm not doing the -u, so this should tell us the bulk transfer speed between those two. And so we see both numbers. I don't know why it dropped off like that. That's kind of interesting. Chances are that ODG, you've been up for a long time. As far as I know from your stream, you haven't eaten in way longer than you should have. Don't make me come back to your stream and donate. better go get something to eat, my friend. But happy to chat sometime, and the VOD will be up for sure, and I'll probably edit something down for YouTube as well. Right, so we remember, let's see, it's still up. So remember that speed test claimed I could send it around 20 megabits per second. Our iperf test just now, where's that window? There we go. Our iperf test just now was actually running, well, my sender thought it was trying to send faster than that. It doesn't know any better. That's how TCP works. So about a couple of seconds in, you notice that there's this retry column. We lost some packets. That's why we got that low performance, because it had to back off and retransmit a bunch of stuff. I think if we ran this long enough, we would end up with somewhere in the neighborhood of 20. And of course, the server, doesn't know whether I retried or not. It just knows what it got. Okay. So that's the bulk transfer, and of course that was for my sending. There is a way. There is a way to tell it to. Oh, there we go. I can send both at the same time. We'll do that. We'll just do a reverse now. For now, all right. So I'm going to have it run backwards. See if that works. All right. So what it's supposed to do is have the server over on the left-hand side. It's supposed to do the sending. So that should simulate the download. Let's see what that does. Yeah, so we see we get a much bigger number. Let's look at the servers. It's sending. All right, so it's trying to send. It topped out at around. Remember, speed test said I have 400 odd download speed, but that was from a data center in Columbus. This is from the campus of Ohio University. Heaven only knows what devices they have in the path and what they're doing along the way. So. Not too, but at least it verifies that we have a much larger download path than I have an upload path. Right. So now let's try to do this for UDP. I'm going to do it this way first. All right, so it's rough. So on the sender side, it should be roughly the same thing. Now on the receiver, of course, it did all sorts of crazy stuff. So we have to run it for longer because it really started with that. It really hit that bug hard. So this, let's see, that is -T, I think. Time in seconds. Okay, let's double the time and see if that stabilizes a bit better. All right, so let's see what we get here. So it messed up again at the beginning, but it should stabilize a little bit now. We wanted to actually make measurements. The nice thing is iperf lets me basically tell it to ignore the first 4 or 5 seconds of transfer, so that would actually be kind of useful in this case. But all right, so this is still perfectly acceptable, but obviously a bit different from what I get inside my house, right? So in this case, I have 2 millisecond jitter, which is not, I mean, that would still make for a perfectly, really good communications environment. And I was on a Teams meeting earlier in the day, and it was perfect. So that network path doesn't have any issues, at least not in that direction. And so what this did, it would simulate. Since we were sending from my house to campus, sort of it's kind of the same thing I do with Twitch right now, and streaming to Twitch. So now let's see what happens if we run this in reverse. Whoops. Let's see what happens if we run this in reverse. So at this point, on the right-hand side, we're the receiver. That's interesting. So so we're getting a lot of loss. Not much jitter, but a lot of loss. Huh. That's interesting. Not sure why that. What's causing that? That could be, again. This is on the university property in their network. I have no reason to believe they're doing traffic shaping, but they could. So there's something that showed up. So these are the kinds of things we want to know, right? So there's yeah, I was thinking about you when I saw that when I saw you struggling with the bit rates on your stream. I thought about it. Just like, this is exactly the kinds of things I'm trying to do. So this, in this particular case, and again, I'm a little concerned, not concerned, but there's always there's obviously a possibility that there's always a possibility that the fact that we're running such an old version on this side of iperf that is messing up somehow. But that's a pretty large loss. That's a pretty large loss. So that really doesn't make a ton of sense, especially not inbound to my house, which arguably should have a larger. But then it might be congested, for all I know, because everybody's watching Netflix and whatever. And so who knows? That might actually be real. But these are the kinds of things that we'd always want to know. Now, if you're streaming like ODG was earlier, this wouldn't have, the previous measurement is what matters, right? Because I'm pushing stuff out. But anyway, so that's interesting. I did not expect that. That's so if I was So I was streaming from that, and again, it's without putting more measurement points in different places. It's not clear whether this is traffic that leaves the university with those losses already. Is there something going on campus that is causing that? Is this being lost someplace else? Is it being lost when traffic comes back to the residential cable network that I'm on and then gets sent to me somewhere along the way? But we're losing a lot of traffic. Interesting. All right, so we're gonna let this machine be. Whoops. Right. So now what I want to do is put a cloud server somewhere and see what happens if we run in a data center somewhere else. Yeah, Odisha, you're right. So what we just saw, of course, was that the download is faster in bulk, like most broadband, as you said, and the upload is considerably slower, right? So I'm running 400 down, 20 up right now. Although nominally my speed is higher, I think the Twitch stream certainly is affecting that to some degree. But that's roughly right. So I'm supposed to be in the 20s up and 400 down, but for some reason my connection managed to send small amounts of time critical data much better than outbound than the server away from me was able to send it in. So that's one of the reasons why I wanted to go through this, because the tools we need have to I needed to find something that that lets me identify if there are issues with the type of traffic we're actually trying to do well. In this case, streaming or streaming or two-way streaming and video conferencing, audio conferencing. And so the bulk tests work perfectly well and showed what I expected them to. But this is sort of surprising. I mean, again, this could be an artifact, right? Because the iperf version that we were sending from was kind of old, so it could have had problems. If you're not careful, it's very easy to overload the UDP buffer in an operating system and lose. So these packets could have gotten lost on the computer I was on, that the sender was on, if they weren't careful about pacing the packets out. The UDP doesn't deal with bursts really well. It expects that sort of orderly progression of packets, and it works really well for that. So it's perfectly possible that the coding isn't optimized yet in that older version. So we'll see. So I think what I want to do is pop up a let's see, I've got a screen open here already. I need to just find it. There we go. So what I'm going to do here, that's probably the last thing we'll work on tonight. What I'm going to do here, this is a cloud provider called DigitalOcean. And it's a little easier for simple stuff like this than Amazon or Microsoft Azure, that sort of thing. But I'm going to have to play around with this with Azure, which is what the university actually subscribes to. If we're going to do this if they want to do this for a class they're teaching, they'll probably want to do it on Azure. But what I'm going to try to do is create a small virtual machine here and see what we can do. So I want an Ubuntu. Shared CPU is cool. I can work with the smallest one possible. I don't need block storage. Where do we want to put this? Singapore. Singapore sounds good. Let's put it in Singapore. Don't need that. In this case, I don't need IPv6, although that'd be another interesting thing. Nah, I don't need that. I don't need monitoring. One of the bad things about, well, there are no really good solutions to this. What's going to happen here? That's one of the reasons I created the SSH key. One of the things that's going to happen here is I need to SSH into that virtual machine, and I can do that with an SSH key. The thing that makes me kind of nervous is I certainly don't want to do it with a password, because DigitalOcean I need really to pay attention to chat more. Yes, Kubernetes are a ton of fun. Yes, we'll have good fun with Kubernetes and Docker and all that stuff. So right now we're just doing virtual machines, um, but there's one of those you can't get there from here problems. You create a virtual machine, you've got to get access to it. How do you get access to it? You have to get access to SSH, right? So um, the DigitalOcean chooses not to create a non-privileged user, and you literally SSH into root, which is kind of nasty because in most cases, for security reasons, you really, really don't want to do that. But at least with a key, that makes a bit more sense. I would not want to do it with password. I think Azure and AWS let you create a user, but it's not really a whole lot better, because that user then has access to privileged commands without an additional password, so it's really not a ton better, other than it's a little bit safe. It doesn't immediately fall prey to all the brute force password hacking attempts. All right, so what we're going to have to do here is upload the SSH key I just created. This time I actually need the key in all its glory. Whoops. Put it right there. I just want that one. I want one of them. All good. Do any have? Okay, let's create the sucker. The other nice thing is that at least the last time I did this, well, then it says it backs up. Last time I did this on DigitalOcean, it was a little quicker than Azure, which takes quite a while to spool up a virtual machine for some reason. Although I've actually had problems spooling up containers on Azure. Most of the time they're up within seconds, and sometimes it takes forever. So I don't know, maybe missing an without if you just create them without an orchestrator, sometimes it just gets confused. I've done this in AWS in ages. I don't know how long it takes. This is taking a little longer than it usually does, but hopefully we'll get this thing up and running here in a moment. All right. So it says we have a machine running. We will copy its IP address. So now I should be able to pop over here. Whoops. There we go. Great. That I didn't expect. Did I mistype? Root at 66.225.177. Whoops. Where are you? Oh, it wasn't ready yet. Cool. So we're in. I'm curious. Yeah, so so our ping time to Singapore is 250 milliseconds, which probably is one of the reasons why it just took a moment to get that. All right, so now what we have to do, so we're in the root account, so what we have to do is this. We'll let that do its thing. There we go. All right, let's give ourselves an iperf instance here. I won't tell. As we sit here and watch the grass grow. Alright, let's let it do its thing. Alright, so I'm curious, how far is I don't want flight time. I want the actual distance. 9,500 miles. 15,000 kilometers. Let's see. Oops, there we go. So Singapore is 15,000 kilometers. So 15 million meters. Actually, I can have that cheaper. 15,000 kilometers over 300,000 kilometers per second, the speed of light. So free space, now we multiply by 1,000. So free space speed of light, free space speed of light is 50 milliseconds from here to Singapore. All right. So the best round trip we could possibly get is 100 milliseconds, and of course we're not running in vacuum, we're running over fiber optic and copper cables. So that adds probably, so that's 15,000. Rule of thumb, it's maybe about 200,000 kilometers per second. So there's 150 out of those 250 milliseconds. 150 milliseconds are just physics. Interesting. I'm gonna make you go away. All right, so looks like we've got iperf 3. Cool. Let's see if we can actually run a server here. You can actually see the delay. Well, you can't. As I'm typing, I can feel the delay a little bit as I'm doing this. Okay. So now Let's just get a regular iperf run here. All right. Right, so we overshot again. I think you can see that again at 4 or 5 seconds. We overshot and had to retransmit, so a speed drop. But it didn't really change that much compared to Columbus, which is 70 miles, not 9,000 miles. Okay, let's do that in. Well, at this point. Yeah, we'll do the reverse. Let's do all of it. All right. That looks like there's something limiting what DigitalOcean lets me do, because it's not. It looks like it's topping right around 100 megabits per second, which may be how the machine is provisioned. Okay, so now let's try and see what happens if we do this with UDP. So this would be more indicative of what happens if I have a video conference with someone in Asia, and see what happens. Slip, you want to time somebody out or ban somebody. I don't want to become famous. All right, so UDP. All right, so what we got? Cool. So that's really cool. Now we're running to a data center, which I guess makes sense. Running to a data center, so our jitter is actually not much worse. Now the delay is bad, so you would definitely tell. You could definitely tell that you're on a long distance connection. If you talk to Singapore on a video conference, it would be lag. You would have problems sort of. It wouldn't feel as immediate because people wouldn't react to you for like a quarter of a second. But the jitter is not bad. It's settling down to the same sort of 2 milliseconds we had in the other case. And now the timing is pretty good. So I'll finish up and I'll run this one backwards and see what happens if I send to myself from Singapore. That's interesting, isn't it? So I'm beginning to wonder about that old iperf version, because that's perfect. I mean, that is just dead on. We have half a millisecond jitter and no loss coming in. That's really cool. So I think the point of all of this is that with sort of the right tools, we can get a decent picture of what we would expect, right? So the point of this whole exercise is I want to be able to use tools that are easy to use. I can deploy these little virtual machine probe points in various places around the globe, wherever there are cloud data centers, or wherever else I can get somebody to run the other side of iperf for me. And so I can get a feel for how I think an application like Twitch or a game or Zoom will perform by looking at these sorts of measurements. I think that's really cool. So it gives us a better sort of ad hoc feel. And then if for someone running a corporate network, I can deploy a bunch of these probes in different parts of my network. And if I have equipment issues or capacity issues that are causing performance problems, this is presumably how it would ferret them out. So let's do a little bit of cleanup here because virtual machines, of course, cost money if I leave them running. So we're going to get out of the server here. Thank you. Exit out of there. Let's go to DigitalOcean. And that machine has done its duty. So we will destroy it. Cool. Right. So we're about 5 minutes from where I wanted to wrap up in the first place. So I think I'm going to call it here. But first, comments, suggestions, questions. We have a few folks in chat. I'm very happy to say we had a number of folks lurking. And ODG, thanks for hanging out with us. I know it's like super late. If you're still here, it's like super late where you are. But if any questions, let me know. So again, this will happen something like this. Next week it'll be next week we'll probably try to figure out if this iperf, the old iperf version, was actually the cause of that loss. So I'm kind of curious about that. Then we'll switch over and do some other stuff as well. And hopefully, this is fun. I certainly had fun. Hopefully you enjoyed hanging out and doing these sorts of things. And again, I'm super happy to talk with folks on Twitter or Discord. If questions or want to suggest something for me to do basically probably several weeks from now, because there's a number of things I really kind of need to do now, and we'll sort of use those as our topic here. All right, so let me see. I think what I want to do. I need to refresh this. Okay, let me hold on a second here. I think what we're going to do is, if I can figure out the controls, there we go. We are going to raid Resurrection Fern and listen to some music if you care to do so. I certainly will. And with that, thank you for watching, and we will, I'll start the raid here in just a second, and hopefully I'll see some of you next week. Have a very good, whatever, rest of the day, night it is where you are, and hopefully I've actually done the right thing here, and we will hop on over to Resurrection Fern. Good night, everybody.